Okay, so these are our notes on equations of circles. And at the top it says, interesting fact, the equation of a circle is based on the distance formula and the fact that all points on a circle are equidistant from the center. I would go farther than based on the distance formula. The equation of a circle is really pretty much the distance formula, just written in a different form, just rewritten slightly differently. So I'm going to go ahead and show you that in a moment. But first, let's go back and look at a couple of problems like the examples you saw in that video. All right, so this was a mashup math video on equations of circles that I have linked for you. The standard form equation of the circle with center HK and radius R is, here it is. And we're going to write an equation for this circle over here. So the two things you always need to know to write the equation of a circle are the center and the radius. So first off, the center of this circle over here is at 1, 2, 3, 4, 1, 2, 3, 4. We have a center at 4, 4. Then to find the radius, you count boxes from the center out to the edge. You can go to the left, you can go up, you can go down, whatever. So don't count the points, count boxes. Don't count like these. Count 1, 2, 3 squares. So that means I have a radius of 3. All right, remember that when we put it in the equation, we always square the radius. If you're looking at an equation, you're looking at a radius square. All right, we don't have it squared otherwise. Outside of the equation, it's not squared, but anytime it's in the circle equation, it's squared. So we're going to write x minus 4 squared, that's x minus my h, here's h, plus y minus k squared, there's k, equals 3 squared. Couple things about this. One, please always do square your value of r. In other words, don't just write 3 squared, go ahead and square it, you get 9. Also, remember, just to reinforce this, you already have seen it though, opposite signs. If I see a minus here, that means the coordinate is positive. So if the coordinate's positive, I'm going to have a minus. If the coordinate was negative, I would have a plus, because minus and negative makes plus. On this next example, I'm going to ask you to draw a horizontal line dividing this box into 2 pieces because I want to do 2 examples in this box. So if you don't want to draw a line, like you don't want it to be an imperfect one like mine, that's fine. Just leave the bottom half of the box empty. All right, so write the equation of a circle with a center of 4, negative 2. So 4 is the h value, the x value of the center, and negative 2 is my k, the y value of the center. And the radius is 3. So I'm going to write x minus h squared plus y minus k is negative 2. So minus a negative 2 becomes plus 2 squared equals, the radius is 3. So 3 squared is what goes in the equation, and that's 9. So this is my answer to that first example. Couple of things to just random details to remember. You always need to have this squared outside the parentheses. This is why we reviewed extensively completing the square, is because we're going to have to do that with some we look at next week. Because a circle standard form equation is always in this form where you have the x's are in a binomial squared and your y's are written as a binomial squared. Okay, so that could require completing the square twice, once for the x's, once for the y's. On this sheet, what we're doing today, we're not going to be completing the square. It's already completed for us. But you definitely need to remember to write the exponents. And remember there's a plus between these. Don't just write 2 sets of parentheses up next to each other. That would mean something totally different. So next question we're going to do is kind of going in the opposite direction. Find the center and radius of the circle with this equation. Okay, so take a moment to write that down. Think about what the center is going to be and what the radius is going to be. Similar to the third example you watched in the mashup math video, if you don't see any number with the x or with the y, that means the number was 0. X is the same thing as x minus 0. So if you just see x squared, that's the same thing as x minus 0 squared. So my center has a 0 for its x coordinate for h. And what is the y coordinate? It's -6. It's always going to be the opposite sign of what you see in the parentheses. So there's my center. The radius comes from looking over here and saying this is the radius squared. Okay, so let's just look at that for a second. If you need to, you can write for yourself r squared equals whatever that is, and then take the square root of both sides. So r is 5. That would be particularly helpful if it wasn't a perfect square. Like sometimes you'll have equations where you might not know, just looking at it, oh, 25, square root of 25 is 5. Let's say it was this instead. 14. If this is what's in the equation, remember whatever's in the equation is always r squared. So this is r squared. So this must be r squared, and I write r squared equals that number, and then I take the square root. So in this particular case, it can't simplify, so r would just be square root of 14. And that can happen. R can be a decimal, r can be a radical. Here it's not though. Here, r is the square root of 25, so r is 5. So those are my answers here. Okay, next it says reminder distance formula, and it just reminds me of what the distance formula is. Now I'm going to say I assume that the reason they do that is because they want me to do this next problem thinking about the distance formula. And that's perfectly fine, and it's a great way to do it, and it's not really any extra steps, but we're going to do it a slightly different way. So let's look at this first. Remember I promised you that I would show you how the distance formula is really just the same thing as the circle equation, right? So let's think about the distance formula. The distance formula is all about finding the distance between 2 points. Now a circle, the definition of a circle is it's the set of all points that are the equal distance or equidistant from a set point, which we call the center. And my center, I'll go ahead and call it HK. So that's how a circle is defined. It's the set of all points that are the same distance. So that means R is always the same, no matter where you draw it. That's what he was saying in the video. So let me just randomly call a point on my circle XY. And that can represent just any point anywhere on the circle. Okay? R is the distance between the center and a point of the circle. No matter where you draw it, that's what the radius is. It's the distance from the center of the circle to a point on the circle. Okay, so if distance formula is this, then I could say that R is the distance between these 2 points. So X minus H, that's the difference between the X's, squared, plus difference between the Y's, squared, would be Y minus K squared. I'm going to rewrite this in the opposite order just because the circle equation usually has R at the right. So let's put it there. Sorry, it's just plain R. I started to write R squared. That's coming soon though, right? Excuse me. All I have to do now to get the circle equation is square both sides. If you square both sides here, voila, we have X minus H all squared plus Y minus K all squared equals R squared. All I did was rewrite the distance formula specific to these 2 points. So it's really just a special case of the distance formula. This is the circle standard form equation, and it's just a special case of the distance formula. So let me go ahead and do this problem the way that I think they're implying I should. I'm going to do that first. You don't necessarily have to write it down because I'm also going to show you what I think is a little bit easier way. So here's the center. It's HK. There are 2 things I need to write the equation of a circle. I need the center and I need the radius. I don't know the radius. But I do know that the radius is the distance between the center, which I know, and any point that's on the circle. And I have a point on the circle. So the distance between these is the radius. So the radius is going to be the distance between those 2 points. So I'm going to subtract the x's, 2 minus 2 squared, plus subtract the y's, 3 minus negative 1 squared. Okay, that's 2 minus 2 is 0 squared, plus 3 minus a negative 1 is 4 squared. So that means my radius is the square root of 16, which is just 4. So now I have found the radius. Let me pause there for you to catch up. And remember, the 2 things I needed were the center and the radius. So now I have them both. Here's the center. So now I'm ready to write the equation. X minus h squared plus y minus a negative 1 becomes plus 1 squared equals r squared. So I got to square the 4, and that gives me 16. So here's my equation. That's a perfectly fine way to do this problem. Okay, and it's really not even that long. So it's not like what I'm going to show you next is really much of a shortcut. It's a little bit of one, but it's not much of one. But I do think it's a more direct route. So what I'm going to show you next is, instead of using the distance formula, since the distance formula and the circle equation are really the same thing, I'm just going to use the circle equation. Okay, they told me the circle passes through this point. That's a point on my circle. So that's like telling me that xy is 2, 3. So I'm going to take the circle equation. I'm going to write it here. And then I'm just going to plug in that x, that y, that h, and that k. I'm plugging in here, 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 here. The only thing I won't have is this plugged in, and that's how I can find that. That's going to automatically give me r squared. So x minus h is 2 minus 2. 2 minus 2 is 0 squared. So I'm just going to write 0 squared. 2 minus 2. Y is 3. I'm just going to write this really small to remind you of what I'm plugging in if you look back at it later. So 3 minus a negative 1. 3 minus a negative 1. Does this seem familiar? It's the same work we just did on the other one. 3 minus a negative 1 was 4. So 3 minus a negative 1 is 4 squared equals r squared. 0 squared plus 4 squared is 16. So r squared is 16. Now I could find r, but I don't need to. I was asked to write the equation, not find r. So technically, if I'm writing the equation, then what I need is r squared, and I have it. So the only shortcut really is that I don't have to take the square root and then re-square it later, because that's really what I did here. I had 16, I took the square root, and then I squared it and got back to 16. This gets me there a little more directly. So now I have r squared, and I have the center. I'm ready to write my equation. X minus 2 squared plus y plus 1 squared equals 16. And that's my answer. You can write it down either way. You can write it down both ways, however you like to do it. I'm going to give you the alternative of putting them both up here, that you see them both at the same time. Let's say, or either way, you're really doing the same work. It's just a different way of writing the same work. Just plugging into the circle formula, I think, is the easiest or the most direct path. The only thing you have to be careful about when you do it this way is remember that at the end, when you are asked to write the equation of something, if there needs to be an x or a y, then I should actually see that. Don't leave that point plugged in. We plugged in the 2 and the 3 to help us find r, to help us find r squared, really. That doesn't mean they're in the final form of the equation. Okay, the final form of the equation whether it's for a circle or a parabola or a line or anything, whatever variables you need to have in that equation, and usually it's x and y. Sometimes it's just one of them, but usually it's x and y. You should see the letter x and you should see the letter y in your final answer. Sometimes we plug in one of the points to help us find something, but then you have to take it back out when you're writing the final equation. All right, so whichever way you choose to do that, and you might want to pause this video if you need to go back and spend some more time writing that down. Here's another problem just like it. So go ahead and try this problem. I'm going to suggest you press pause. So I'll give you a little bit of time to do that. Okay, now I'm going to go over it. So if you still need some more time, hit pause. I'm going to do it what I consider to be the more direct way, is I'm going to take the standard form equation of my circle. Oh, there's a bell. All right, and I'm going to say this is the center, so this is H and K. This is a point on the circle. It says the radius has an endpoint at that point. Well, remember, the end point of a radius is either the center or it's a point on the circle. So since we already know the center is this guy, this must be a point on the circle. So we can call it X and Y to represent just some random point on the circle. And then I can plug in. So I get -3 minus 5 squared. That was this X minus this H. And then over here, Y minus K is 4 minus 4 squared. This is -8 squared plus 0 squared equals R squared. -8 squared is 64 plus nothing. R squared is 64. If we're being asked to write the equation, then R squared is really what we need. You could tell me what R is there if you wanted to. R is what? R is 8. But we weren't asked for R. We were asked to write the equation. So I'm going to go back up here and I'm going to fill in the H and the K and the R. So X minus 5 squared plus Y minus 4 squared equals 64 because that's R squared. And there's my answer. All right, last two problems here. They're actually a little less work. This is one of the more complicated problems we do with circle equations. A lot of what we do with circle equations is very straightforward and quick. This is slightly more complicated. Another thing that's more complicated is when we have to put it in standard form by completing the square. And we'll look at that next week. All right, these, all I have to do is identify from the equation the center and the radius, and then I can graph. Remember from the example, if you see x squared, that's the same as if you saw this. And if you see y squared, that's the same as if you saw this. We don't usually write the -0 because x minus 0 is just x. There's no reason to write it. So if you don't see a number with there, if you don't see parentheses, that means your x value of your center, the h, must have been 0. And if you see the same thing for y, that means the k must have been 0. Okay, what's the radius here? The radius squared is 9, so that means my radius is 3. Here's how to graph a circle from the equation or from that information. Go make a dot where the center is supposed to be, and then take the radius and say, I'm going to go that many units in each direction, meaning up, down, left, right, almost like compass points, north, south, east, west. Go up 3, go left 3, go down 3, and we're cutting boxes. Go right 3, and then draw a circle that goes through those points. It can be hard to do, but do your best. It can be easier to like take a pencil or something and sort of sketch it around and around, just do like feather strokes. That can be easier. All right, last one. I need to know the center and I need to know the radius to be able to graph this. So the center, remember, take the opposite signs. The center is -1, +2. The radius is 2 because the 4 is the radius squared. So I'm going to go to -1, 2, and then I'm going to go up 2, left 2. Why 2? Because the radius is 2. So that tells me how far to go from the center to the edge of the circle. And then I'm going to make the best circle I can that goes through those points. And that is it. All right, so if you are in my class, and this is March 3rd, what I want to tell you about your homework is earlier this week there was a Delta Math. The Delta Math had distance formula, midpoint formula, slope formula. Some of you did it, some of you didn't quite get finished. I have gone back and reopened that for full credit and added 9 problems on circle equations. So Sunday night at 10 p.m., you have the opportunity to go back and get full credit on any that you did not do in that assignment. It's the, I think it's like coordinate geometry basics or intro to coordinate geometry. It's the same assignment from earlier this week. Finish that, including the new circle problems that I just added today. If you already did the other problems earlier this week, you'll just go back and finish those last 8 or 9 problems. And I will see you when I see you on Monday. Remember, we have the weird testing schedule. Thanks for watching.